Our speaker today is Cesar Guareschi, and he is a master's student with Dr. Chuck Rice, and he's transitioning to a PhD student. And so today he will be presenting his talk titled The Effect of Crop Intensification and Diversification on Soil Health Indicators. So Cesar, the floor is yours. Please go ahead.
All right, thank you, Sai. Let me just share my screen here. Can you guys see my screen?
Yes, we can see your screen.
All right, so today I'll be talking a little bit about one of my chapters from my dissertation. It's the second time actually I am giving an update here at the Rainal Scientists meeting, and thank you so much, Sai, for the invitation again. And you'll be discussing today the effect of the intensification, diversification of cropping systems on some soil health indicators. Oops. Yes. Okay, so as you know, the crop productivity lags in the southern Great Plains, mostly because of the heavy reliance on continuous wheat, the summer fallow cropping systems. That's why our research here emphasizes that perhaps more intensive diverse cropping systems have the potential to improve soil health indicators and also carbon sequestration on those systems. However, the effect of this intensification and diversification of cropping systems on soil health indicators remains unknown. That's why, just before moving forward, I'd like just to step back a little bit and understand what is soil health. I know that we have people from different backgrounds, and so soil health, by definition, is the continued capacity of a soil to function as a living ecosystem, sustaining plants, animals, and humans. And we measure soil health through a set of different indicators, either chemical, physical, and biological indicators that are affected by several factors, such as land use management, soil type, the climate, the inputs that we use on these cropping systems, and the cropping systems by itself. And the benefits of having a healthy soil would be an increased soil biodiversity, aggregation, and enhanced nutrient cycling that will lead to a more stable, economically talking, stable cropping system and resilient cropping system as well. And we believe that we can achieve this through intensifying and diversifying our cropping systems. And that's why the objectives of this research were to assess the temporal changes of the soil health indicators over a 3-year period, and also assess the cropping system effect on these soil health indicators under the hypothesis that the more intense diverse cropping systems will enhance soil health. For that, our research locations are the rain plots located in Ashland Bottoms, just outside Manhattan, where we have a Weimar silty clay loam soil type in an experimental design as a randomized complete block design with 4 replications, where we assessed all the soil samples on 6 different treatments. So here is a sketch of the 6 different treatments that were assessed in this study, starting with treatment number 1, the control, just a simple sequence of winter wheat and summer fallow. And all below that, we were adding more intensity, meaning the number of crops inside our cropping systems, and also diversity, meaning not only the number, but also the type of crops in our system. So you have treatment 2, a sequence of dual purpose wheat intended for grazing or hay production, and for soybean intended for hay production. We have treatment number 3, semi-intensive, with addition, it's only a sequence of winter wheat and soybeans with 1 period of summer fallow. We have the intensive treatment with addition of sorghum and corn, and also triticale as a cover crop in the system. We have a dual purpose semi-intensive system with addition of 2 summer fallow periods, and also the addition of triticale intended for forage production. You only have a dual purpose intensive with addition of moth beans and alfalfa as well as triticale and wheat for forage production. And samples are taken in 2019 and 2023. So this is just a big picture from the whole data set that we are generating, either through biological, chemical, and physical soil health indicators, as I mentioned before in the definitions. But for today's presentation, I will be focusing on biological indicators, on the microbial composition, as PLFA, phospholipid fatty acids, in total microbial biomass, total bacteria, and total fungi, and enzyme activity, divided in 4 enzymes: beta-glucosidase related to the carbon cycle in the soil, N-acetyl beta-deglucosaminidase, which I kindly say NAG because it's way easier, related to the nitrogen and also to the carbon cycle in the soil, est phosphatase related to the phosphorus cycles in the soil, and iosulfatase related to the sulfur cycle in the soil at a depth of 0 to 5 centimeters. And statistically talking, we analyze these results with a linear mixed model with each specific soil health indicator as a response variable, and using treatment, year, and interaction between them as explanatory variables, and the blocks or repetitions as random variables, followed by an analysis of variances. And after that, the mean differences were extracted using a 2-key test. So this is just the summary of the p-values from the ANOVA, and we could observe that we had a treatment effect, a significant treatment effect just for beta-glucosidase, and we have a near effect for beta-glucosidase to the microbial biomass, to the bacteria, and to the fungi, and a two-way interaction, significant two-way interaction between treatments and year for acid phosphatase. So moving to the results, here I have the results for total microbial biomass represented on plot A, total bacteria on plot B, and total fungi on plot C. We can observe an increase on these indicators when you compare 2019 to 2023. However, with no treatment differences on these indicators. Moving to beta-glucosidase activity, we had a significant effect of year and also for treatments, where we can see also that, we can see that lowercase letters indicate the difference between treatments, and uppercase letters in the plot indicate difference between years. And we can observe that we had higher beta-glucosidase activity in 2019 when comparing to 2023. And one thing that was really interesting, that you can see in the red boxes, that the treatments that had crops intended for hay production or dual purpose that had biomass removal revealed the lowest activities for beta-glucosidase in 2023. For acid phosphatase activity, remember that we had a significant two-way interaction between treatment and year, where the upper cases in the boxes represent the difference between the 2 years, and the lowercase letter represent the difference between the same year. And you can see a really similar trend to beta-glucosidase, where we have the treatments with intending to hay production with this biomass removal and not the return of this biomass to the system, revealing lower activity for acid phosphatase as well. Even though we didn't have significant results for iosulfatase and neither for NAG, we can see a really similar trend in 2023 for these two enzymes as well. Here I am showing iosulfatase, and you have the same 3 treatments where we have low diversity in the case of semi-intensive, just using wheat and soybean, and the treatments with biomass removal, adaptive forage, and the dual purpose semi-intensive with lower enzyme activity. And this is for NAG. We could also see the same trend with the same 3 treatments with this biomass removal, the treatments intended for hay production or for dual purpose production, revealing lower enzyme activity. And then after that, we wanted to try to find what are the answers for that? So we started thinking, is the use for example, intensity indexes, diversity indexes, the correct way to be evaluating the systems? And then here, I know that this slide's a little bit crowded. You can see a lot of information on there, but keep attention to the last column where we have the cumulative biomass production for each one of the systems, where we have the biomass, above ground biomass determined for each one of the crops in each one of the cropping systems at the harvest or mow stage. And the below ground biomass was also estimated using some root to shoot radius according to some literature. And you can see some really big differences on cumulative biomass between the treatments after these 3 years. And then just to answer that, when we plot the four enzymes activities representing each one of the boxes against the intensity indexes, we can see a negative correlation between intensity indexes and enzyme activities. And then it reinforced our way to think that, is this the correct way? Maybe it's too subjective way to be evaluating the systems. And then when we plot the same enzyme activities, the 4 enzyme activities, with the cumulative biomass that was returned to the system, that was produced and not taken away from the system, we start to see a positive trend on these activities of enzymes that are considered for sure soil health indicators, where we had like the higher biomass production and return, we had higher enzyme activity, and this was a way for us to put numbers on these systems, and we started to see this positive correlation. So just to sum up some of my conclusions, just answering the hypothesis, more intense and diverse cropping system will enhance soil health. Well, seeing for these results, not yet. And since the research area was conducted under conventional tillage system until 2019, before the start of the rain project over there, probably we are facing the benefits, at least in the microbial community, of no-till for now, since we're not seeing any significant treatment differences. And also because it is a short-term analysis, it's only 3 years. And we could also observe that we had overall lower enzyme activities after three years, and a really significant difference observed in treatments with no or low biomass return. And also we saw an overall increase in microbial community of 3 years, however, with no significant difference between the treatments. And some takeaway messages for that is that we did see that intensity indexes were considered a subjective way to evaluate the systems, mostly because we had this negative correlation with enzyme activities, and also that crop residue management is essential to enhance soil health, as we saw this positive correlation between enzyme activities and the biomass production and return. And also that intense and diverse cropping systems do have the potential to improve soil health indicators with the correct crop residue management, meaning that the biomass produced should stay in the system, providing substrate for the soil ecosystem in quantity and quality. And for future steps, I believe that's really important to track these changes over time. So maybe doing a soil health assessment for the 5th year, for the 7th, maybe the 10th. I don't know, maybe if you get the extension cost for that. But it's really important to have this baseline in tracking changes over time to see if there's a grading, sustaining, or degrading soil health over time, and also to assess all the viability of the different systems. So with that, I would like to acknowledge USDA for funding this project, all the RAIN colleagues and professors that contributed and are contributing to this research, as well as the Soil Microbial Agroecology Lab here at K-State. With that, I conclude my presentation. I would like to thank you for your attention, and I will be more than happy to answer any questions that you might have.